Howdy. Mountain water, white rivers. Once again, and it probably won't be the last time. One of the best examples for having a wide river and something so called special beside it is Mount St. Helens in the USA. It is a volcano. It has the world's fastest growing glacier in its caldera. And it has several wide rivers attached to it. There are many other wide rivers that are all over the world. Here are a few examples. Montmort in France, Nalchik, Russia, Udine, Italy, Parma, Italy, Walgau, Germany. I think the Alps and many other mountains are mainly created by electricity, which burn hole through the crust and mantle, and they made a connection to the waters below. And as this discharge event went on, it created mountains. Huge mountain ranges all over the world. And I've been talking about this a lot. And I still think it's important. There is some activity going on all over the place, but let's pick out just one quake somewhere in the Alps. So I have now zoomed in as far as needed. You can see we have many water veins all over the place. They are starting just somewhere. And a quake yesterday in Squall, Grisha, Switzerland. Here we can actually probably, I'm not saying it is so, but it could be that there is slight movement going on in this hill. We have these lines. And we have a water vein very close to the quake. Let's see if we can zoom in to measure it. "13 meters according to this application. So it is rather close to a water vein, and they originate, as drawn here, just out of the mountain. Many millions of people they rely on the water which is coming from the mountains. Wherever you go. Is it the Alps? Is it the Himalayas? Is it whatever mountain range? People know that there is water coming out of the mountains. And there are very interesting things going on. Here we had the fire on top of a glacier, Glacier 3000, to ancient people known as the Le Diablere. I have been there several times. And on the right here we have a picture from inside the glacial cave, which is somewhere here on top of the mountain. And there is this red stuff. And I'm asking, is it iron deposits in the glacier ice? I have been asking this some professional from Switzerland, but he then said that he doesn't know. I should ask some geologist. And I'm still waiting for answers. And here, not too far, approximately 33 kilometers away from Glacier 3000, we have Kraftort Krimiwasser, a place of energy. And we have an iron well, which is really red. It contains a lot of iron. So I was asking them, is it possible that there could be iron deposits also in the glacier? He doesn't know. Back to the map. Let's go to our earthquake hotspot. Where is it? Isn't there any action going on at the moment? Matterhorn, it must be somewhere here. Now, at the moment, there isn't. There is. Yesterday, I have been talking about this spot a lot. Mer de Glace, the ocean of ice, or the sea of ice. And I think glaciers are contemporary lava streams made of water. Because there is water coming out from the ground. Even the Bible talks about it. And I still think it would be very, very well possible that there are so many volcanoes which erupt just by water. Because we have so much water everywhere, also in the ground. Acidic and alkaline water. It depends on the geology, on the charge of the whole thing. And the water has been retreating recently. But I think it will come back. Like glaciers are shrinking and all this kind of stuff. Rivers are drying up. Rhine, Po, and many other rivers. And probably they will flood once. Because they have been doing this all the time. And I just found today an article about water. So there are many, many glaciers in the Alps and many glaciers elsewhere, and where we don't have glaciers, if we just pick out some random hill, this might be a hill or mountain, we have those lakes. They are all over the place. And I think most of them are fed from below. It doesn't really depend on the size of them. Let's see if we just find another one quickly. And also these patches of ice. These might be also sources of water from below. Like this one here, that's a nice example. Here it's dark, so it must be rather deep there in the middle of the lake. And there are smaller water bodies. There might be a little flow, keeps the soil wet. Now here's another one. And if, for example, this lake would be in a region where we would have permafrost, it would be more or less frozen all the year long. It probably would form a glacier. And the fluctuations of the water amount and quality, it might fluctuate. It won't be always the same. Okay? So sometimes there's a really big load of water coming out there. Like an eruption. So now let's go to the article. That's a rather recent article, I guess. Scientists find evidence of ocean hundreds of miles below Earth's surface. That's from today, I guess. That's a picture. And note. That's rather deep. So, now let's try to make this somehow work. I haven't read this fully. Researchers say they found new evidence of an ocean deep inside Earth. After analyzing an extremely rare diamond, believed to have been formed at a depth of around 410 miles below Botswana, an international team of researchers concluded in a new study published in the Journal of Nature Geoscience that the boundary between our planet's upper and lower mantle, a region known as the transition zone, which reaches hundreds of miles into the Earth's interior, holds far more trapped water and carbon dioxide than previously thought. And I've been talking about this spheres within spheres within spheres. There is a whole sphere of water within the Earth. And as the energy circuit of Earth and our solar system and galaxy and so on. As they fluctuate, the size of the bubble will vary accordingly. It will either shrink or expand. When it expands, there will be water pouring out of the ground everywhere, especially in places where it is already doing that, like mountain springs, glaciers, and all these kind of things. The lakes in the mountains. The transition zone, TC, is the name given to the boundary layer that separates the Earth's upper mantle and the lower mantle. It is located at a depth of about 410 to 660 kilometers. The immense pressure of up to 23,000 bar in the transition zone causes the olive-green mineral olive, which constitutes around 70% of Earth's upper mantle and is also called peridot, to alter its crystalline structure. At the upper boundary of the transition zone, at a depth of around 410 kilometers, it is converted into denser red slate. At 520 kilometers, it then metamorphoses into even denser ringwoodite. So they are talking about transmutation of the elements. These mineral transformations greatly hinder the movements of rock in the mantle, explains Prof. Frank Brenker from the Institute of Geosciences at the Goethe University in Frankfurt. For example, mantle plumes, rising columns of hot rock from the deep mantle, sometimes stop directly below the transition zone. The movement of mass in the opposite direction also comes to a standstill. There might be a double layer. There is a double layer for sure. Brenker says subducting plates often have difficulty in breaking through the entire transition zone, so there is a whole graveyard of such plates in this zone underneath Earth. Maybe not. Maybe there is no plate tectonics at all. But I will talk about this in another video. However, until now it was not known what the long-term effects of sucking materia into transition zone were on its geochemical composition and whether larger quantities of water existed there. Brenker explains the subducting slabs also carry deep-sea sediments piggyback into the Earth's interior. These sediments can hold large quantities of water and CO2. Who is your guardian angel? I guess those people don't even know what an angel is. But anyway, do we have? Yes, it continues here. But until now, it was unclear just how much enters the transition zone in the form of more stable hydrous minerals and carbonates. And it was therefore also unclear whether large quantities of water really are stored there. The prevailing conditions would certainly be conducive to that. The dense minerals vadislight and ringwoodite can, unlike the olivine at lesser depths, store large quantities of water. In fact, so large that the transition zone would theoretically be able to absorb 6 times the amount of water in our oceans. So, we knew that the boundary layer has an enormous capacity for storing water, Brenker says. However, we didn't know whether it actually did so. An international study in which the Frankfurt geoscientist was involved has now supplied the answer. The research team analyzed a diamond from Botswana, Africa, which was formed at a depth of 660 kilometers, right at the interface between the transition zone and the lower mantle, where ringwoodite is the prevailing mineral. Diamonds from these regions are very rare, even among the rare diamonds of super deep origin, which account for only 1% of diamonds. The analysis revealed that the stone contains numerous ringwoodite inclusions, which exhibit a high water content. Furthermore, the research group was able to determine the chemical composition of the stone. It was almost exactly the same as that of virtually every fragment of mantle rock found in basalts anywhere in the world. This showed that the diamond definitely came from a normal piece of the Earth's mantle. In this study, we have demonstrated that the transition zone is not a dry sponge, but holds considerable quantities of water, Brenker says, adding, this also brings us one step closer to Jules Verne's idea of an ocean inside Earth. The difference is that there is no ocean down there, but hydrous rock which according to Brenker would neither feel wet nor drip water. Hydrous ringwoodite was first detected in a diamond from the transition zone as early as 2014. Brenker was involved in that study too. However, it was not possible to determine the precise chemical composition of the stone because it was too small. It therefore remained unclear how representative the first study was on the mantle in general, as the water content of that diamond could also have resulted from an exotic chemical environment. By contrast, the inclusions of the 1.5 centimeter diamond from Botswana, which the research team investigated in the present study, were large enough to allow the precise chemical composition to be determined, and this supplied final confirmation of the preliminary results in 2014. The transition zone's high water content has far-reaching consequences for the dynamic situation inside Earth. What this leads to can be seen, for example, in the hot mantle plumes coming from below which get stuck in the transition zone. There they heat up the water-rich transition zone, which in turn leads to the formation of new smaller mantle plumes that absorb the water stored in the transition zone. If these smaller water-rich mantle plumes now migrate further upwards and break through the boundary to the upper mantle, the following happens. The water contained in the mantle plumes is released, which lowers the melting point of the emerging material. It therefore melts immediately and not just before it reaches the surface, as usually happens. As a result, the rock masses in this part of Earth's mantle are no longer as tough overall, which gives the mass movements more dynamism. The transition zone, which otherwise acts as a barrier to the dynamics there, suddenly becomes a driver of the global material circulation, whatever that is. The story above is based on materials provided by Goethe University Frankfurt. So, let's go back quickly to volcano discoveries. Poás volcano, dormant at the moment. Eruption style, phreatic eruptions, sometimes geyser-like ejections of water from the acid crater lake. Poás is one of Costa Rica's most active volcanoes and one of its most frequently visited and prominent ones. It contains a green acid crater lake, and during some of its frequent phreatic eruptions, water from the lake is ejected like a geyser. In other words, mountain water. There is water coming out of a mountain, like a giant geyser. Let me show you still one thing. Actually, there are two. And that's from Switzerland, the map. And here we have Bortelsee. We will take a closer look at this very quickly. It goes down to the valley, and here we have a planned geothermal energy plant and a thermal bath. Not too far. That's the Bortelsee. Let's start up from here. It has a caldera-like shape. And I think it's mainly fed from below, Why I think it is like so? It is so. Because it has a circumpolar pattern in the middle. As it would spread from the middle. And this goes all around. Furthermore, it's not that well visible, but there are like different colored sediments here. Like if there would have been once some eruption. Like this stuff, which is, I think this is here, I'm not very sure anymore. It got pushed that way. That's why we have the sediments here. So there might be coming more out of these mountainous lakes than just water. And there can come quite much all of a sudden. This is why I was writing about this. I think it's very important because many people could be very surprised about sudden flash floods in the Alps, mudslides, and stuff like that. Because they don't understand that there's probably water pushing from below. And the amount and quality of the water will fluctuate according to Earth's electrical circuitry. According to the size of the water sphere within the mantle of Earth, which is held in place by the same mechanisms as our atmosphere and magnetosphere is held in place. And there seems to be very, very much water beneath our feet. And as long as the water is in a lake shape, let's put it like that, a bulk of water, it doesn't react really strongly to electricity. But if it is in rocks, it does it much more because then we have easy water all over the place, which creates its own electromagnetic field, surface tension. Then we have quartz in the rocks, which also create electricity through piezoelectricity. Hence, an earthquake could trigger a huge surge in electricity in a mountain just because the quartz gets squeezed. And if it's surrounded by a lot of water in the rocks, hydrophilic, then this might have rather big influences in the surroundings on water rains, on weather, lightning, or whatever natural fluctuations we have. There are many. We have iron springs, we have sulfuric springs, we have alkaline springs, we have all kinds of water coming out there. And there's a lot of water inside Earth, not seen yet. But as I mentioned already earlier, even the Bible is talking about water pouring out of the ground. And there are many other tales on Earth, religious or not, which are talking about the same thing. So there must be a sphere of water in the crust of Earth which differs in size. If it grows, water will pour out of the mountains. If it shrinks, the rivers dry up. And it's all linked to the electromagnetic environment of our solar system, galaxy, and the interplay with the rest of the universe. We are all capacitors in space as Earth is. We are charged bodies, so we will interact with our environment in many levels. Levels of awareness, consciousness, ignorance, hate, love, all these. And every charged body has now and then to get rid of the too much energy received. It will discharge. And there are many, many different kinds of ways for charged bodies to discharge. For example, crying is a discharge event too. Laughing probably also. All these emotions are discharge events. So, since Earth is a living organism, it will discharge as well if the stress gets big enough. But anyway, water, mountain water. Very interesting. Thanks.